All right, this is the 2018 BC exam FRQ number 4. So part A says use the data in the table to find h prime of 6, and we're approximating it. So h prime of 6 is going to be approximately h of 7 minus h of 5 over 7 minus 5. And then to get those units in there, I'm going to say this is meters for the y-coordinate, years for the x-coordinate. So that's 11 minus 6 over 2. So that's 5 over 2 meters per year. And they want us to say the meaning in the context of the problem. And so we're going to say the height of the tree is increasing by this much per year at the exact moment when the t-value is 6, or at when the tree has been planted, I'm guessing, for 6 years or whatever. So the height of the tree all right, part B says to explain why there must be at least one time between 2 and 10 where h prime of t equals 2. So for me, when I see that interval, I automatically think, okay, so that average rate of change from 2 to 10 should be 2. And then when I looked at it, I was like, ooh, it would be 15 minus 1.5 divided by 8. That's not quite 2. So then I started to look to see if I could find another combination in here. And I was like, well, that's 5. That's an odd number. That's not going to do it. 11, that's 9. 10, I was kind of mixing it around. And then I realized that if I do these two, then I do get that slope of 2. So what I did is I was thinking first the different things you have to do for the mean value theorem, which is what this is because it's a slope. And so I said, since h of t is twice differentiable, then it's also continuous. So because it has to be continuous for, sorry, excuse me, coronavirus. That's a joke. I don't have that. 210. That was a bad joke. I apologize. Sorry if anyone was triggered by that. So we need to do h of 5 minus h of 3 over 5 minus 3. Which is 6 minus 2 over 2, 4 over 2 is 2. So now we can say by NVT, there exists some C on 3, 5 such that h prime of c equals 2. All right, part C says to use a trapezoidal sum with 4 subintervals indicated by the data in the table to approximate the average height of the tree. So average height of tree, and then they also gave you that you needed a sum, which should make you think of integrals. So the average height would tell us that we're going to do 1, 10 minus 2. That's the part that allows you to get the average value. And then 2 to 10 of h of t dt. And so we're going to have 1/8, that's the part that makes it the average. And then we have 1/2, that's part of the formula for the trapezoid. And then for the first one, we have a width of a trapezoid of 1, and then 1.5 plus 2. and then 2 plus 6, and then 2, 6 plus 11, and then 2, 11 plus 15. And I kind of wrote this bad here. We're going to put a big bracket there because it's 1/8 times the entire thing. All right, so I went ahead, since we've got the 1/2 here, I went ahead when I did it and just pulled that 1/2 out with the 1/8. And so 1.5 plus 2 is 3.5. 2 plus 6 is 8. Times 2 is 16. Sorry. 6 plus 11 is 17, times 2 is 34. And then you've got 26. Oh, that wasn't 2, that was a 3. Sorry, that last trapezoid was a width of 3. So 26 times 3 is 78. I did that work off to the side when I did it before. And then if you go ahead and add all of those up, you end up getting 131.5 over 16, or you can leave it here, or you can probably leave it there. So any of those answers is good, or some variation of that would be fine. All right, part D gives you g of x, and they start giving you all sorts of different information. So x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, which is what g stands for, it's the height of the tree. The diameter is increasing at a rate of 0.03 meters per year. What's the rate of change of the height of the tree? So part D is basically a related rates problem. And so I said, okay, we've got g equals 100x over 1 plus x. We have the height of the tree is 50. We have the rate that the height is changing is what we're trying to solve for. We have that x is the diameter of the tree and that dx dt is 0.03. So we don't know what x is, but it's not the goal of what we're solving for. So what I did first is I just went ahead and set 50 equal to the equation so I could go ahead and solve for x. So I can multiply the 1 plus x to the other side. So that means that when the height is 50 feet or whatever, then the diameter is just 1. Okay. So from there, I said, okay, now let's do this as the related rates question. So I've got the derivative of g, so dg dt, rate of change of that, equals the derivative of the right side. So I've got low d high minus high d low divided by low squared. All of that is multiplied by the derivative of x, dx dt, the derivative in terms of like the rate of change of x. Okay, so at that point I said, okay, let's plug in everything that we have. We don't need to plug in the 50 because there's no place where the g is all by itself, but I can plug in the 1 and then I can plug in the 3/100ths. I always do fractions because for me that's a little bit easier. Okay, so dg dt is 1 plus 1 times 100 minus 100 times 1 times 1 over 1 plus 1 squared, and that's being multiplied by 3 over 100. So I've got 2 times 100 is 200, so 200 minus 100 over 2 squared is 4. 200 minus 100 is just 100. This 100 and this 100 cancel, and we just get 3/4. And then the growth was the height of the tree, and so the units there would be meters per year. I can't remember if you needed that or not, but there it is if you did.